Welcome to physics! The purpose of this lab is to determine how launching a projectile horizontally at varying velocities affects its time of flight.
I have a question.
Yes.
What is a projectile?
I'm glad you asked. A projectile is the motion of an object thrown into the air, and after the initial force that launches the object, it only experiences the force of gravity. This object is called a projectile, and its path is called a trajectory.
The most important thing to remember in the projectile is that the y-axis and the x-axis are independent, which means they aren't related in this case.
The apparatus used for this lab was composed of a clamp, a projectile launcher, a small ball, a smart gate laser, and a time of flight pad. The clamp was used to hold down the base of the projectile launcher, and we used a small metal ball as the subject of our launch. The way we were able to calculate the velocity at which the ball was launched was with the smart gate laser. The smart gate laser is made up of two lasers that read the ball's movement as it passes by and gives us the initial velocity. The last part of the apparatus was the launch pad, and that was used for the flight time. Once the ball landed on the pad, the time would stop and give us the total time of flight. It is also important to note that the launcher was placed at 0.98 meters from the ground.
So here's our result for the experiment. We firstly found in the experimental values that were between 0.44 and 45, and theoretically we find 0.45 as a result. And compare, we found that 0.44 is the average, and 2.2 is the percentage error of the experiment. So basically, how we found the theoretical value is that first we mean the average of the trial 1, 2, 3 for the first click, which was the lowest speed. We took the average as the velocity. Then we knew we had 0.98 meters per second, and we want 5 times in the air. So what we've done, we took the initial speeds square minus initial speed square time equal 2 times 9.8 times delta D, which equal 4.4 meters per second, sorry. Now we took the second formula, delta D equal Vf plus Vy over 2 times delta T, and we find an answer of 0.45 seconds.
For the theoretical time, we obtained 0.45 seconds, and the average data obtained in the lab gives us an average of 0.44 seconds. In the end, the velocity at which they are launched has no effect in this situation.
From this lab, we understand that the y-axis and the x-axis, for example, of a projectile, are completely independent from each other. Which means that even if two projectiles are thrown at two different speeds, one very fast or one slow, they will both touch the ground at the same time, because the y-axis is the same for the two projectiles, and the acceleration is 9.81 meters per second.
Stay tuned for next class where we'll be talking about buoyancy force.